Well, I haven't done one of the very common toss a ball or toss a rock or anything like that type problems yet, so I thought I should probably include one of those in my set of videos here. We started with the geometry one. We did another one, which is actually very similar to this, but, you know, we've got to include that. So here we go. We've got Lupe. I have no idea how to pronounce either of these names, so I'm just going to pretend. Lupe tosses a ball up to, yeah, I'm not even going to try that. We're just going to call him Q. So Lupe tosses a ball up to Q, waiting at a third-story window with an initial velocity of 30 feet per second. She releases the ball from a height of 6 feet. The equation h equals negative 16t squared plus 30t plus 6 represents the height of the ball after t seconds. If the ball must reach a height of 25 feet for Q to catch it, does the ball reach Q? So here we go. First thing is, let's look at the information that's given to us. It gives us an initial velocity of 30 feet per second. Now, hopefully you've recognized by now, I mentioned in the last video, but in case you didn't watch it, it's giving us this information, but it's already here. There it is. The number in front of the linear term will be the velocity. All right? Now, it also says a height of 6 feet. This is the beginning height, the initial height. That's right here. That's the number that's being added on in the end. The last problem with the space shuttle, there wasn't a number there. That's because the space shuttle starts on the ground. Okay, so this one, the ball is starting 6 feet up. Now this first number, you may remember from the rocket ship, the space shuttle, the last one, is the acceleration. Now, when a ball is in the air, it's actually accelerating because gravity's pulling down on it. So it's causing it to slow down as it's going up, and then it speeds up as it's coming down. So it's changing its speed constantly. And so that acceleration for gravity is negative, well, will be related to negative 16. This is actually half of it. It's actually negative 32 feet per second squared. And so that's where these numbers come from. Again, this is half of the acceleration. So here we go. We can now deal with the equation at hand. So it tells us if the ball must reach a height of 25 feet for Q to catch it. So that means we're going to make, and they actually were very, very nice here. They said substitute 25 for H. So we're going to go 25 equals negative 16t squared plus 30t plus 6. Now, it says, it gives us an even bigger hint to use the discriminant. The reason why it's saying that is because in order to solve this equation, right, to solve for t, we're going to have to make it equal to 0. So let's subtract 25. And then we'll go 0 equals negative 16t squared plus 30t. And then that's minus 19. Now, the question actually asks here, does the ball reach Q? Okay, it doesn't ask for when does it reach Q, which would be a completely different question. It just asks if it does. Okay, well, if we are now solving this equation for the time at which it reaches 25 feet, or when it reaches Q, then really all we need to do is solve for t. And so if we're solving for t, it's often very helpful to check the discriminant first. So let's check the discriminant, which is b squared minus 4ac. Now, if you're having a hard time remembering that, you should just write down the whole quadratic equation. X equals, because most of you are actually fairly good at the quadratic equation now, negative b plus or minus b squared minus 4ac all over 2a. Now, the reason why I say that is because the discriminant is this, right? And then the other part of the quadratic formula, the negative b over 2a, is the axis of symmetry, or x value of vertex. Okay, so by writing it out, you knock down 2 stones with one blow. You only have to memorize one equation instead of 3 separate equations, the quadratic formula, the discriminant, and the axis of symmetry, or x value of the vertex. So now if we do that, let's go ahead and we'll go 30 squared, because b is 30, minus 4 times a, which is negative 16, times c, which is negative 19. All right, so let's pull out our handy-dandy calculator, and we are going to go to the home screen, because we're just going to type in 30 squared, and then we're going to subtract 4 times negative 16 times negative 19. And you'll find when you work that out, you get negative 316. So negative 316 is the discriminant. What does that mean? Well, hopefully you remember that if the discriminant is negative, that means there are no solutions. In this case, meaning no x-intercepts, but it also means that there are no solutions for t that will make this work. Now, if there aren't any solutions, then does the ball reach Q? The answer is no. It doesn't. Now, let me ask a further question. How high does the ball get? What's the highest that it reaches? Okay, obviously we've determined that it doesn't reach Q at 25 feet, but how high does it go? So, just for the fun of it, let's go ahead and look at that. How do we know where the maximum point is? Well, hopefully you can see that this question has a negative leading coefficient. And we learned that a negative leading coefficient means that the graph is a parabola that's concave down. And so the maximum would be right here, which has a special name, which is the vertex. So how about that? We'll find the vertex. So we'll go x equals negative b over 2a. So negative, and then b was 30, over 2 times a, which was negative 16. And so we've got negative 30 over negative 32. And so if we do that, so negative 30 divided by negative 32, and then we'll approximate that with the little green squiggly equal sign there, which is 0.9375. So 0.9375 seconds, because the x values are in seconds. So that's the time. Now we can plug the time back in to find out how high it is at that point. All right? And so, oh, schmack. I just made a mistake, didn't I? I just did the whole vertex for the wrong equation. So I should be finding the vertex of the original equation, so I apologize for that. I really should go redo this video, but class is about to start and I don't have time. So b is 30 over 2 times a is negative. Oh, just kidding. It's the same thing, isn't it? Oh, Mr. Bywada, you're such a kidder. You're such a kidder, man. So it's still 0.9375. The big deal is, though, that when I plug it in, I'm putting it into the original equation. So h equals negative 16 times 0.9375 squared plus 30 times 0.9375 and then plus 6. Now my recommendation is that through all of this we should have been using our calculator. Even if you don't know how to find the maximum and minimum, you should be able to punch this in. So if I go to y equals and I clear what's there and I type in the equation, which is negative, oh, where's my negative? There it is, negative 16x squared, and then we go plus 30x. And I know you're saying, why are you putting into x, Mr. Bywada? What you doing, man? Well, I'm just going to remind you that once you have the equation in and we've graphed it, then we can pick any x value and type it in. Now, I can actually see part of the graph here. We're going to adjust that. We don't actually need to adjust it. We'll look at that in just a second. But you can plug in any value because we can do some math. Go to F5. And remember, you can go value. And you can type in 0.9375. And it will give you the y value. And it tells you that it's 20.0625. So the maximum height is 20.0625. So that's the height of our vertex, because that's what we were solving for here, was the vertex, right? So we found the vertex. So the maximum height is 20. Well, no wonder it couldn't get up to 25 feet, because it only goes to 20. Now, you actually didn't have to do all of this, believe it or not. You could have just gone to your calculator, and you can see the curve here, right? You can see it down here just a little bit, and then it curves up, and then it comes back down. And so we know the maximum is somewhere in that range. Now this window is kind of messy, so it may or may not be what we want. You can mess with the zoom. You can mess with the window if you want. In fact, I'm just going to go zoom. I'm going to go zoom standard, so zoom 6. So let's see what it looks like if I do that. Okay, so see there, I can see it a little bit better. I'm going to go ahead and change the window so I can see up to the top a little bit better. It looks like it goes well over 10 for the y values. So let's change the y value. We know it doesn't go to 25, but let's just try 30. And so let's graph it. And so now you should have a pretty good view of what the graph looks like. We're looking for the vertex. We're looking for the maximum height. So let's go into math, F5. And so you could have done this before you did the discriminant, before you did the quadratic equation, before you did the vertex. This could have all been done at the very, very beginning. And you can just go to maximum. You can say, okay, find the maximum, lower bound. I got to make sure I'm to the left of the maximum. Push enter. Upper bound, so make sure you go to the right of your maximum. And then it's going to find the maximum for me, which interestingly enough is 0.9375 for the x value. Woo, looky, there it is, look, there it is, look, there it is. And then 20.0625 for the maximum height, which again was in feet. And so there you go. Not only did we find out whether it got to Q, but we found out how high it got. Now, I guess the next question would be, okay, what needs to happen so Q can catch it? Is he going to be able to hang out the window? Is he going to need some type of net? But that's his problem, right? So we're all done for today. I hope this was helpful. Ciao.